Hello, my name is Agung Julius. I'm an associate professor at the Department of Electrical, Computer and Systems Engineering at RPI. Today I would like to tell you a little bit about my research in the control of circadian rhythm. The circadian rhythm is a very important aspect of our lives. This is the process that regulates when we wake up, when we feel sleepy or drowsy, when we are alert, when we are hungry. It also regulates various processes such as our core body temperature. It is long known that the circadian rhythm is heavily modulated by the light that we receive. My research, which I'm doing in collaboration with my colleague Professor John Wen, is about how we can regulate the human circadian rhythm when we view it as a control system. So the main idea is that the circadian rhythm, which you can see here in the middle of the slide, is the process that we would like to control or regulate. And we do so by deciding the kind of lights that the subject should receive so as to regulate the circadian rhythm. Now we do this by forming a feedback control loop by extracting information from the subject through the use of smart wearables. So we extract biometric signals from the subject, and then we use information that we extract from the signal to decide what is the best light that we should introduce to the subject. There are a number of key ingredients in this research. The first one being the mathematical model that describes the system that we want to regulate, which is the circadian rhythm itself. The next ingredient is the sensors that allow us to extract the biometric signals and some signal processing algorithms that allow us to extract useful information from the signal. Next, we have control algorithms that compute the best lighting or the best schedule for lighting that we should provide to the subject. And then finally, we have smart actuators in terms of smart lighting systems that can implement the control inputs. To give you an illustration of how it works, think about the case where you are traveling across multiple time zones. So you are right here as a traveler, and as the result of your travel, your circadian rhythm is misaligned with the local reference circadian rhythm. So this is an illustration to show you that although both you and the local reference have functioning circadian rhythm, as a result of your long distance travel, you may be out of sync. So the question is, how can we schedule your light exposure in such a way that you can catch up with the local reference, which means that you eliminate your jet lag as quickly as possible. Our research has multiple potential applications. Jet lag recovery is something that I just mentioned, but we are also looking at how we can use this knowledge to ensure the well-being of shift workers and to optimize alertness during missions for critical missions. Thank you for your attention.